Hey there. Okay, first of all, open your notebook to page 47. So you should have this page that you see here. If for some reason you don't have your notebook, or if for some reason you don't have this page. So if you don't have your notebook, take a piece of notebook paper, pause this video, and write down all of the words that you see here. We're going to then fill in that information, and we're also going to be answering questions through Edpuzzle. If you do have your notebook, however, you do not have this piece of paper, then do the same thing. Take a pencil, write down the questions, keep the spacing about the same, and then as we watch the rest of the video, we'll fill in these correct answers as we're also answering questions in the Edpuzzle video. When you combine two or more substances called reactants, the atoms interact, rearrange, and produce new substances called products. Hey, we already know that. Reactants are on right here, the left-hand side of the arrow, and the products are on the right-hand side of the arrow. A chemical reaction takes place. Some chemical reactions take place quickly, such as a burning match. Others require more time, such as chains left outside for a month exposed to weather, which causes the iron to react with the oxygen in the air, producing a new compound called iron oxide or rust. This overall reaction can be described in writing with the following chemical reaction equation. So here are the reactants. Here's the product. Remember that 4 is a coefficient, so that means that there's 4 iron atoms. Remember that this 6 is a coefficient, and then this subscript 2 on the hydrogen. Multiply those together, you get 12 hydrogen atoms. And then this 6 coefficient also applies to this O, so there's 6 oxygen atoms here. And then look right here. This coefficient 3 and this subscript 2 multiplied together makes 6 oxygen atoms, so 6 more oxygen atoms. And then if you take all of these atoms and you rearrange them, see how this 4, subscript 4 in front of the iron? Well, there were 4 iron over here as well. Now this is where it gets a little bit tricky. This outside 3, this subscript outside, and this coefficient 4, multiply that together, and that gives us 12 oxygen atoms, which, wait a minute, that's what we had over here. Here there were 6 oxygen atoms, and then this O right here with this coefficient, there were 6 oxygen atoms here as well, so they've been rearranged together like this, but there's still 12 oxygen atoms. Let's look at the hydrogen. So this outside 3, this subscript 3, times this coefficient 4, well, that's 12 hydrogen atoms. And sure enough, there were 12 hydrogen atoms here. So we didn't gain any more atoms, and we didn't lose any atoms. They were just simply rearranged. So again, a chemical reaction, a process by which 2 or more chemical substances interact and are chemically changed, producing different chemical substances. That is exactly what has happened here. This is so amazing. So this Fe is iron. We know that H2O is water. And we know that O2 is oxygen. So when you take iron, water, and oxygen, they rearrange into this chemical compound called iron oxide. Take a look at the pictures below of a smelly, rotting pumpkin, a burning campfire, and some tarnished silverware. These images are examples of chemical reactions taking place. In each image, how do you know a chemical reaction is taking place? Okay, so here we see the pumpkin, here we see the campfire, and then here we see some silverware. Sorry that this isn't in color. So we can observe evidence of chemical reactions. Scientists confirm that a chemical reaction has occurred by determining if a new substance with new properties was formed, sometimes using instrumentation. In most chemical reactions, there are signs that indicate a chemical reaction has occurred. If you observe one or more of these signs, this provides evidence that a chemical reaction might have taken place. 5 possible signs of a chemical reaction are the production of gas, production of light, unexpected temperature change, unexpected color change, and the formation of a precipitate. These signs can be helpful as long as we remember that the only way to be certain about a chemical reaction, that a chemical reaction has occurred, is to identify a new substance that was produced in the reaction. Remember, not all chemical reactions will produce one of the 5 signs, but these are 5 different signs of chemical reactions. Here's one: color change, fall leaves, a precipitate, light here, and then here we see heat change, and then of course gas with the bubbles. So production of gas. Mix sodium bicarbonate or baking soda with an acid such as vinegar. What do you see? The products of this reaction are water, carbon dioxide, and a substance called sodium acetate. During this reaction, you can see bubbles in the solution, as shown at the right. These bubbles are caused by the carbon dioxide gas escaping into the air as the reaction takes place. The chemical equation for this reaction is as follows. So here you see the chemical equation for vinegar plus the chemical equation for baking soda. So these are the reactants, and then here are the products: sodium acetate, water, and carbon dioxide. You can ask your parents if you can do this at your house in the sink. This is actually a way that some people help clean their garbage disposal. They put a bunch of baking soda into their garbage disposal, and then they pour in a bunch of vinegar and let it bubble. We personally just put lemons or limes in our garbage disposal and turn it on, along with ice cubes. So also the production of light. The burning of logs in a fireplace is the reaction of compounds in the wood rapidly combining with oxygen. Combustion reactions, such as this one, require a heat initiation source to get started. Wood is made of cellulose and a combination of different substances that contain carbon, hydrogen, and oxygen. When this reaction occurs, a large amount of energy is produced in the form of heat and light. This reaction is similar to the reaction that produces the bright light and heat in fireworks. And remember that this is an exothermic reaction because heat is being released in this case, and it feels hot. So change in temperature. Chemical reactions can either give off heat or use heat. Perhaps you have had an injury and have applied a chemical heat pack to the area that creates a reaction that produces heat. When the heat pack is activated, the magnesium sulfate reacts with the water and produces heat, which you use to soothe your injury. Chemical cold packs work in the opposite way when a chemical like ammonium nitrate is mixed with water. That combination absorbs heat, or it takes it in, creating an endothermic reaction, and it feels cool to the touch. These temperature changes are evidence of a chemical reaction. Formation of a precipitate. A precipitate is a solid substance that forms and separates from a solution and often settles to the bottom of a liquid reaction. One common chemical reaction that forms a precipitate is the reaction of a solution of lead nitrate and potassium iodide. Each of these substances in a solution is clear and colorless. But if you mix a solution of each substance, lead iodine and the potassium nitrate form as products. Lead iodine is insoluble, so it separates from the solution as a yellow precipitate. It's shown right here at this image, but it's not in color. That's why I gave you that video. The potassium nitrate remains in the solution. The chemical equation for this reaction is as follows, right here. Now remember, the reactants are always on, can't get my cursor there, sorry, the left-hand side, and the products are always on the right-hand side.